right, welcome back. So in this video, we are going to talk about precipitation. So it's section 6 in your textbook of chapter 17. And we're going to be looking at determining whether a precipitate will form when you mix two solutions. Now, we did in the past in Chem 1, just look at the solubility rules and check your products of the double displacement reaction, but there's more that goes into it. So we're going to be looking at, rather than the solubility rules, we're going to be looking at the KSP values and seeing how that relates to determining whether or not a precipitation reaction occurs. So a little bit of review. Remember that precipitation is the formation of a solid from a solution. The solid that forms is then called the precipitate. And if you remember back from last unit, we talked about Q. And so Q is the ion product, and it's set up the exact same way as the equilibrium constant, the difference being that Q uses the initial concentrations rather than the equilibrium concentrations. So if you have an aqueous solution of calcium nitrate and it's mixed with sodium fluoride, what is the ion product for calcium fluoride? And so we would just take this and take calcium fluoride and write it as Q is equal to the concentration of the calcium ions times the concentration of the fluoride ions squared. And it's squared because there are two fluorine ions. And if you weren't able to recognize that in the formula, remember that you can just write the equilibrium expression, and any coefficients become powers in your exponents in your equilibrium or your Q expression. And the only difference here when you're using the ion product expression, you need to make sure to include these little zeros after each concentration to denote that you are looking at your initial concentrations and not the equilibrium concentration. Okay, so how does this work? So we talked a little bit about comparing Q and K in last unit and how you can determine if equilibrium will shift towards the reactants or the products based on the value of Q and how it compares to K. Same sort of thing can be used looking at precipitation reactions. So we can compare Q versus the KSP of a particular substance and determine if a precipitation will occur. So if Q is larger than the KSP, then a precipitation will occur, and it occurs until the concentrations are reduced enough to satisfy the equilibrium, the KSP. On the other hand, if Q is less than the KSP, then we would say that no precipitation occurs. And so this diagram here on the right side of the slide just sort of walks you through the process that you would take every time you were given a question like this. And so if you had two ions, let's say the cerium ion and the iodate ion, and someone asks, will a precipitation reaction occur between these two ions? So we would first determine, as it says here, this is our step 1, determine the initial concentrations, and you would have to be given information in the question to do that. Once we have that, we're going to look at determining what the ion product is. So essentially, we're going to find Q. So that's our step 2. And finally, we're going to compare Q versus the KSP. And if Q is greater than KSP, so the answer is yes, then a precipitation will occur. If Q is not greater than K, or it's less than K, then we would say no, a precipitation does not occur. Now, if the answer is no, a precipitation does not occur, the question would probably then be over. However, if the answer is yes, a precipitation will occur, the free response question would then oftentimes go one step further to ask you to find the equilibrium concentrations of that particular precipitate. And in order to do that, we would then apply the equilibria icebox that we did in a couple videos ago, which I will explain to you in an example in the next couple slides. This is very important, so make sure that you put that in your notes and memorize that for your test and also for the AP exam. So here's an example I've worked out using the little flow chart in the last slide. So the question is this: a solution is prepared by adding 750 milliliters of a 4 times 10 to the negative third molar solution of cerium nitrate, and it's added to 300 milliliters of a 2 times 10 to the negative second molar potassium iodate. And the question is, will the cerium iodate precipitation occur. And I gave you the KSP for this particular substance. So as it said in the low flow chart, step 1, calculate the initial concentration. Now I'm mixing two solutions, so in order to calculate the initial concentrations after the solutions have been mixed, I'm just going to use the dilution equation. So your M1 and V1 would be what you have in the initial question. So for the cerium, this would be your M1 and your V1. And for your M2, that's what we're trying to find. Your V2 is going to be the sum of the volumes. So the 750 plus 300. And again, it has to be in liters. So I've converted to liters here. When you do the math, you get this as your initial concentration of the Ce3 plus ion. We're going to do the exact same thing for the iodate. The iodate is going to come from the potassium iodate solution. So the 2 times 10 to the negative second would be your M1. 300 is your V1. Your V2 is going to be exactly the same as the previous question because you're using the same solution. And this would then be your initial concentration of the IO3 minus ions. You can then use these two concentrations, set up your Q expression, solve for Q, and you get that Q is equal to this, 5.32 times 10 to the negative 10. Then step 3 is to compare Q to K and determine whether a precipitation will occur. So we're going to look at the value of Q, which is this, and the value of K that I gave you in the question. And so by looking at these two numbers, I can say that the value of Q, 5.32 times 10 to the negative 10, is in fact greater than the KSP of 1.9 times 10 to the negative 10. And because Q is greater, a precipitation reaction will occur. And the CeIO33 will in fact precipitate out of the solution when these two are mixed. And that would be the end of this particular question because it didn't ask you to go any further. In the next example that I'm going to show you, I'm going to walk you through the same calculation, but I'm going to take it one step further and go through what you would do if the question then asks you to find equilibrium concentrations of the ions in the precipitate. Here on the right side of the slide is the step-by-step instructions of the step-by-step procedure of how you would go about answering this question. So again, I give you the two initial solutions that you're starting with. So you're looking at a magnesium nitrate solution and a sodium fluoride solution. And the question is to calculate the concentrations of the magnesium and the fluoride ions at equilibrium with solid magnesium fluoride. And I've given you the KSP value of MgF2. So here's the steps. So the first 3 steps are exactly the same as what we just did in the previous slide. So we're going to first find the initial concentrations of the 2 ions we're looking at, magnesium and fluoride. Step 2, we're going to find the value of Q. Step 3, we're going to compare the value of Q versus K to determine if a precipitation reaction will occur or not. And that's what we did in the last slide. And then after step 3 is where I'm going to add something new. So step 4, we're going to run the reaction to completion. So we're going to figure out what our limiting reactant is and what our excess reactant is. And I'll show you how to do that. After you've done that, and you'll see in my calculations that we're going to determine based on the information in the question that magnesium is limiting and fluorine is in excess. And so we're going to step 5, calculate the concentrations of the excess fluoride ions. And finally, step 6, we're going to determine the concentrations of both of those ions at equilibrium using our KSP value. And this should be our final answer. Now, this is just the overview, the 6 steps that I'm going to take, and I will walk you through all 6 of those steps, but I just wanted to outline them for you so you can see all on one slide. But I will take you step by step each one. Okay, so step 1, find the initial concentrations. So again, we're to do this, as I described in a couple slides ago, we're going to use the M1V1 is equal to M2V2 because we want to find the initial concentrations of our ions just after the 2 solutions are mixed. Now in this example, the numbers that I've chosen are so small that I used millimoles, and because I used millimoles, I kept it as milliliters, and I apologize if this is confusing to any of you. Just keep using moles and liters. I just used really small numbers, and I didn't want to have to make these, times 10 to the negative fifth or something you could have. And so I just, whatever. So we calculated the initial concentration of the magnesium and the fluoride using the dilution equation. And remember that your final volume is going to be the sum of the two volumes that you're given in the question. And I got my two concentrations. Step 2, using the ion product expression of your initial concentrations, I found the value of Q. In comparing the value of Q versus K, we found that the value of K is smaller, so the value of Q is larger than the KSP, and so solid magnesium fluoride will form. That's the same as we did in the last step. Now, steps 4 through 6 are the new part, and so we're going to be using those to figure out the equilibrium concentrations of the two ions. So step 4, we're going to use a new little box. It's similar to your ice box. I'm just not using the ice box because we're not really at equilibrium yet. And so the acronym that we're going to use is BRA. So B for before reaction, R is the reaction itself, and A is after the reaction. Now, students in the past like to call it a bra box. I don't really care what you call it as long as you remember how to use it. So we're going to run the reaction to completion. So the reaction that we're going to use is the formation of the solid, so the two ions coming together. Now, before the reaction, so the difference between the bra box and the equilibrium box, the ice box, is that in this box, the bra box, we're going to use moles, whereas in the ice box, we use molarities. So for the before the reaction, I took the molarity and the volume of our magnesium solution to figure out the moles of the magnesium ions before the reaction. I did the same thing with fluorine. Now, again, I apologize for putting it in millimoles, but you can keep it in moles. And we have not formed any solid yet, so the before the reaction number of moles of magnesium fluoride is 0. Just like the icebox, the reaction, you're going to know it proceeds to the right. So we're going to do minus x minus 2x because of your coefficient, and then plus x here. Looking at the 2 moles, we have 1.5 millimoles of magnesium and we have 25 millimoles of fluorine. And so because of that, we know that magnesium is going to be in excess. And so because of that, our x value, which is right here, is going to be 1.5 for both. And so the way that you determine how much is lost in the reaction is just by looking at which one has a smaller number of moles. So 1.5 is smaller than 25. So I'm going to take 1.5 and subtract 1.5 to get 0. So that means magnesium is our limiting reactant. I'm going to do the same thing for your fluorine. 25, which is your initial number of moles, subtract 2 times 1.5, and you get 22 moles of excess. So after the reaction is done, you get 22 millimoles of the fluorine, and then add 1.5 to your magnesium fluoride, and there you go. We're about to do an icebox, and so because we're going to do an icebox, we need concentrations. So after the reaction runs to completion, all of the magnesium is gone, so I don't care about that. We're going to use the 22 millimoles to figure out our concentration of the fluorine, and so that's step 5. So this 22 comes from the initial reaction. Our 400 milliliters comes from the adding of the two volumes. So we have 150 milliliters and we have 250 milliliters. So that's where that came from. And so we get our concentration of the fluorine. The final step is to set up your ice box, and I only have a few seconds left, so I'm going to go through it quickly. We will do more examples in class. But looking at the dissociation of the magnesium fluoride, solids are not included in the equilibrium ice box. Your initial concentration, as we saw with your limiting reactant, is 0. This concentration comes from step 5. Set up your ice box, take your two equilibrium concentrations and plug them into the KSP expression. We're going to assume that 2x is much smaller than your initial 5.5 times 10 to the negative second, which allows the 2x to go away, making the math a little bit easier. Solve for x, and you will get your two concentrations of magnesium 2+ and your fluoride ions at equilibrium, which is the final answer to the question that's being asked.